In this video, I'm going to walk you through Lesson 9 of Unit 7.1 from Open Sci-Ed. Okay, so we just read in Lesson 8 an article about Dalton's experiments, and we brainstormed some ideas of how we might replicate those experiments. And so this lesson is all about adding energy to water to see if we can do what Dalton did. Now, this lesson is adding energy through heat. And so very important that you have a hot plate already heating up water before students come in. You need it to be bubbling pretty quickly when students come in, and you're going to need to collect the water vapor, and I'll go through the setup with you as you are doing this. Now, if you do not collect enough water vapor by the end of the day, you definitely will need to collect some more or get some distilled water because what we're trying to figure out here is that the density of water is always the same, and the substance that's coming off the heated water is actually water vapor. It's not a new substance. So that's the aha. Do not give it away too early. Let's go through and see how we do this. So first of all, we navigate into the lesson by discussing why we want to add energy to the water. Make sure, again, you turn on that hot plate. Hopefully it's already a little bit warm. You turn it on. It's going to have a flask on it with about 100 to 150 milliliters of water to start the discussion. Here's the slide that you will use to just kind of bring those ideas back to the surface. Why do we want to try to produce bubbles by adding energy to water? So thinking back to Dalton's experiments, what are we trying to do? We're trying to figure out what that gas is made of. And maybe this is going to help us figure out what the gas is made of in the bath bombs. And so we're also trying to figure out what happens to particles. Do they break apart? So this is kind of leading us to figuring those things out. And so we thought that we could test some properties of these gases, and one of them being flammability, the other one being density. So this is a very big density lesson. So we begin by setting up our notebooks. It's pretty simple. They're just going to title a new page in their notebook, and they're going to write down some observations. And then we heat the water, and we observe that it bubbles, just like the bath bombs, they bubbled. So we have bubbles in the water, and we're wondering what those gas bubbles are made of. And so we're going to test the flammability of the gas coming out. So let me show you the setup for this investigation. Here's the teacher reference. So here's your hot plate. You have your flask on top. You're heating it up, about 100 to 150 milliliters of water. It's going to obviously start to bubble. So you're talking about the bubbles and observing them. It'd be really cool if you had like a dot cam that you could point at this so they could stay in their seats. They don't need to gather around. Now, this you want to set up before students come in. It's a cork with a hole in it. I think it has the rubber stopper number in the materials list. But you can see that there is a dropper that goes through the hole, and then the pointed end is in the tubing, and then the other end also has a dropper. The dropper part's off. It's just the glass part of the dropper attached to the tube, and there's some directions on how to connect it. Do this before students come in. You might need to heat up the tubing so it's a little bit more pliable, and slide it over those glass droppers. Take the rubber squeezer off and slide it into the hose. Be careful though, made of glass, it can break. And then you'll see that this is the flammability test. The bubbles are coming up and into this tube. This should look familiar because we did this with the helium when we did the helium flammability test. And so the gas is coming out, and guess what? The flame goes out. So we talk about why. Maybe there's a lot of gas being pushed out and it blew it out. Or maybe it's not flammable. It's probably not flammable. Okay, so that's our first properties test. And then we decide, okay, well, let's test the density of this. And how would we do that? Well, we notice that there's some water droplets that are collecting on this tubing. And so we decide, let's collect this water, or sorry, don't call it water. We collect the droplets, this clear liquid. We collect it in this Erlenmeyer flask because we're going to test the density of it. And so you're going to need to collect some each class, and then it depends on if you have block period or not. You're going to then test the density of this, what we call the unknown liquid is in here. We're trying to figure out what this is. Okay. So that is your setup. And then we notice that the clear liquid is also being collected. I already went over that. And we problematize how we can determine one clear liquid substance from another. And this is where we think, well, we need to measure the density. So we reintroduce the role of density as a property, that these properties do not change. And we're going to begin the investigation. And here is the handout. It's called Density Calculations of Clear Liquids. Now, it starts off by making some predictions. It says, what do you predict the mass would be if they doubled the volume of the liquid measured in 20 milliliters? And so we're saying that a 10 milliliter amount is 8 grams. And so if it was 20 milliliters, how many grams would it be? And hopefully the class says 16. It doubles. And what if we half it and we put it to 5? How much would the mass be? And hopefully they say, well, it would be in half, it would be 4. So what we're trying to show here is that the mass and the volume are predictable, that they're related to each other. And if we change the volume to half, the mass is also going to be cut in half. So we're looking at these as measurable quantities that are predictable. Okay, so here students have a data table. Now, students are going to be divided into groups. If you have 8 groups, half of the class will do the rubbing alcohol, the other half of the class will do the glycerin, and then everybody's going to do the water. So everybody will do water with this row, and then this row, just have them right here. Are they doing rubbing alcohol or are they doing glycerin? And so they're going to first record the initial mass of the empty graduated cylinder, and then they're going to mass the graduated cylinder with the liquid in it. And then they're going to subtract the mass of the graduated cylinder from the combination, which will give you the mass of the liquid. Now, I don't know why, but math doesn't transfer from the math classroom to the science classroom. So I'm sure you will have to support this in some degree, but wait till you get to the density. So you're going to have a little bit of math in this lesson. Now, then they're going to measure the volume of liquid. Now, if you haven't done this already, you're going to need to talk about how to measure the volume of a liquid and what a meniscus is and how we look at that curved line and we take the bottom of the meniscus. And so there's a lot of measuring tools in this investigation. Use them in this moment to teach students how to use them. You don't need to pre-teach. You do it as needed. And so we are using the balance, our digital scales, and we're using the different graduated cylinders. And so now we've got these measurements of milliliters and grams. And so we are going to calculate the density. We're not quite yet. They're going to fill this out, save this one. We'll do this one as a class. Okay, let's go back to our storyline. Okay, so now we have reintroduced the role of density. We assign the groups, they do their lab, and then we transfer our measurements to sticky notes and create a class graph. So one student will put the information for the sticky notes for water. The other student is going to do this for their rubbing alcohol or glycerin, and they're going to transfer it to a sticky note, and we're going to put them on a class chart. Now, these class charts you're going to have to pre-make. You can reuse them from class to class because students will put a sticky note on here. You can also do sticky notes on here, or if you write on here, this will need to be redrawn for each class. But students are going to come up and let's say I think this is done in partnerships. And so you're going to have one partner come up and put the volume and the mass for the water. And then there's going to be another place in the room where you have the same charts up for glycerin and rubbing alcohol. So a student's going to come up and put their measurement of volume and their measurement of grams. Okay, so once we've done that, we're going to graph the data. And so the graph is going to look something like this. And we're going to notice that there's a proportional line. So this is actually really key for density, that no matter what the volume is, you can predict the amount of mass if you know the density, because it's going to fall on this line. It's a property of matter. And when we calculate the density, notice this, they're all about 1. And so we're going to see that proportional line. So it's a big aha moment that no matter what volume we had, and no matter what mass we had, when we calculated the density, we all had about the same density because it's a property of matter. We're going to do this also for glycerin and for rubbing alcohol. Okay, so after we created the graphs, we're going to record those patterns. You're going to they'll put them in their notebooks, and then they're going to calculate the density and add it to the class chart. I already talked about that. And then we determine the average density of each. And so this would just be adding up everybody's calculation of density and doing an average. And then we're going to record it on our handout. So we will have an average density of water, glycerin, and rubbing alcohol. And then we are going to calculate the density of the unknown. So this is the water you collected in that flask. We're not sure what those gas bubbles were made of, and there was some liquid on the tube and in the flask. What is it? Well, we're trying to show that sometimes new substances are made, sometimes it's the same substance. And in this case, it is going to be the same substance because we're going to get a density of about 1, which if you compare to our other average densities, we know that it's water. Okay, now, once we have calculated the density of the unknown substance, and I think you're going to probably do this in front of the class. You're not going to have enough sample to let everybody do this. So just you go ahead and measure some volume and some grams and you calculate it, let them put it on on their handouts. But you might want to ask, what would happen if I doubled the volume? Or if I doubled, what's going to happen to the density? Well, the density is going to stay the same. It's a property of matter. Okay, now we're going to write a claim evidence reasoning. Now, no matter how you've developed this in your class, use your strategy. You can do a CER format. We have a poster that we already used from lesson 2 because we've been developing this practice along the way. And so students are going to first evaluate and improve alternate arguments. Here's a handout. So we've got part 1, there's 2 students that came up with 2 arguments. And one is that the gas is in the bubbles is made of water particles. This is because the properties help prove whether 2 substances are the same or different. And then we have another student who says if a sample of something is made of the same particles as another substance, then it has the same properties. They're basically saying the same thing. So now students are going to support this claim right here. The gas in the bubbles is made of water particles. Now it should have been an aha because we got that same density, but can they now put our evidence and reasoning together with this claim? And so this is basically your claim, your C. This is where they will put their E, their evidence, and then this is where they're going to put their reasoning, which is a key model idea that connects your evidence to your claim. Now there is a second section, and this is saying that it's not enough just to list the evidence and the key model ideas. We need to actually construct an explanation. So how can we include in our arguments other things that make the case that the bubbles are filled with water particles, and there is an answer key of what to look for. So depending on how much writing your kids are willing to do or you want them to do, you might have a different format for this, like a CER format, and it's just a one and done, or you can have them write the full out explanation, and that's what's prompted in the slides. Okay, there's your answer key. It shows you what you should be looking for in student arguments. The most relevant thing is that we have the same densities. That's got to be in there to get a passing grade on this. And I would say this is something I would grade. And then evidence is something we collected. It could be that it put out the flame, or that it was clear liquid. These are things they could also add, but what really needs to be there is the density. And then reasoning, the 2 key model ideas would be here, that properties don't change for a substance and density is a property. So hopefully they caught that as you went through this lesson. All right, let's go through the materials prep. There's quite a bit of prep to this lesson. in the next video.